Oi. Oi. Okay, where do I want to start? Senor. I may have a problem. And that problem is heat. So, the pad on the switch, or post on the switch, is bigger than the port on my solder sucker. So, it's going to be a real pain to get that switch out cleanly. And also, it just sucks up a lot of heat. Ooh, that one came out clean though. And there's a little piece of wire. And there's a switch. And put that in that pile for now. Okay, the reason this one's being such a pain is they wrapped that cap around it. So this is just a bulk filtering cap, so apparently they had a noise problem around the CPU and had to add some more capacitance to it. So it sort of makes sense what they did there and why they did it. They just happened to pick a resistor pin to get it all hooked up. Okay, let's see if we can pop these. Oops. Another 138. Here's a 125. So, cleaned quite a bit of logic out of this side of the card, which will drop the current requirements quite a bit. And now I want to go and poke through what's left in this connector and see if there's any other chips that I can just be like, oh, yep, don't need it, get it out of there. Okay. So where do I want to start? Now, I really mushed the heads out of these when I took them off on the back side. So 1, 2, and 3 on the back. 4. So it looks like these pins were no connect on both sides. 1, 2, 3, and 4 here, I bet go to that 125. Which then also goes to this pull-up resistor? Yes, it does. So this 125 here and these resistors are the pull-ups on the key matrix. And then let's see what else. These two came from the other guy. That looks like either power or ground. Let's see. Yeah, it's power. So there's plus V coming in. 2, 3, 4. Let's see, top side. These go down to this 125. I think. No, that goes... Oh, poking the wrong ones. Gotta make sure you poke the right ones. Now there's this one last resistor over here. He went to that hole, which is 4 up. So definitely these 2 chips can go away. But the question is, what about this last pin? 4 over on that chip. Now these guys should all be chained together. Yep. Yep, yep. Yep, this is one big 8-bit input. Now the question is, where does it come out? Must be on the other side. Poopy. This is not going to be just a straightforward. Oh, pin 1 to pin 2. Oh no, I just jumpers. Somewhere. These guys get an enable signal from, and I'm not seeing it. These 2 are inputs. This is all blocked off except for this path here, but it's going to a cap, so that's pretty sure that's a disable. What I can do is I can pull these chips, and it'll be easier to see on that side what's hooked to what. But these 2 here are hooked together. He doesn't go anywhere. And that snakes its way around and hits this pin, and probably that pin as well, which hits these 2 pins, snakes around, hits this pin, hits that pin. But again, it doesn't leave that area. Now these 2 do, but these are probably address bus. 1, 2, 3, 2, 3. Yeah, it's gonna be that pin. Poke on this and poke on the same pin over here or over here. It's a different address bus or address data bus. It's a little surprising. There's a dedicated bus between these 2. So that's interesting. I still believe there's an enable, so let's pop these 2 chips off and see what's under them. And maybe it'll just become perfectly clear at that point. So here you can see it coming around, hits this, hits that one. It definitely does not leave the circuit anywhere. Now if I flip it over, it's 1, 2 in. 1, 2 in. Right there goes to that one, that one, that one, and that one. So it hits them all. So it must come off the second chip on the top side. Nothing there.